Module 8 continues with Part B, OpenNMS polling. This video will cover topics included in the Horizon Operations documentation under Deep Dive Service Assurance. Service assurance includes tracking the availability of a service and the service response time. Node and interface outages can be correlated to a critical service. The main component of service assurance is Pollerd, which runs the service monitors. When the service monitor detects an outage, Pollerd sends an event that creates an alarm. Pollerd generated events include node lost service, where critical services are still up, just a particular service is lost. Node regained service, that service came back up. Interface down, a critical service on an IP interface is down, or all services are down on the IP interface. Interface up, the critical service on that interface came back up. Node down, where all critical services on all IP interfaces are down. The whole host is unreachable over the network. Node up, some critical services came back online. As an example, and using ICMP as the critical service, in the first column, only the HTTP service is down on a single interface, so Horizon generates a node lost service event. In the second column, the ICMP service is down on the first interface, so Horizon generates an interface down event. Horizon deems all the other services on that interface as down. There are no issues with the second interface. In the third column, ICMP is down on both interfaces, so Horizon generates a node down event. Horizon deems the interfaces and all the services under those interfaces as down. This helps improve efficiency within Horizon. Horizon does not spend resources polling services that are most likely unavailable. The Pollerd configuration files are poller-configuration.xml. This contains service monitor configurations for service availability checks and global daemon configuration. A restart is required when monitors are created or removed. A reload event loads changed configuration parameters of existing monitors, but it will not load new monitors. Response-graph.properties contains the RRD graph definitions for service response time measurements from the monitors. Poll-outages.xml defines scheduled maintenance windows when polling should not occur. This can be reloaded with the event shown. The global daemon Pollerd configuration elements in poller-configuration.xml are shown. It takes one thread to poll one service. The service poll timeouts are, for the most part, 3 seconds, and the polling intervals are, again, for the most part, 300 seconds. This means that Horizon can poll 3,000 services in the polling interval of 300 seconds, or 5 minutes. This is effectively a low estimate. If all the polls were concluded within 2 seconds, Horizon could poll 4,500 services in 5 minutes. And if the polls all finished within 1 second, Horizon could poll 9,000 services within 5 minutes, and so on. This is applicable to Horizon operating with or without minions. If polling requirements span hundreds of locations with hundreds of nodes each, Pollerd blocking may not be possible. If minions are being used, that is when the asynchronous polling engine can help. It allows threads to be released while polls are active. The number of concurrent asynchronous polls also has to be set. Outages are kept in the OpenNMS database outages table. That table is linked to the events table for the service lost event ID and the service regained event ID. The table is also linked to the IF services table, which is linked to the service table. Using that information, run the query shown to get a list of outages. This query selects the outage ID, service name, service lost time, lost event service regained time, and regained event. The events are trimmed, as you will see. Run the SQL in PSQL. Note the last outage ID is 10. The next outage ID is drawn from the sequence outage next ID using the sequence select next value outage next ID. Returning to PSQL, run the select. The value just has to be greater than the max ID returned in the previous query, which was 10. The next outage ID will be 15. If a service is known to be unresponsive at times, setting service unresponsive enabled to true will generate a service unresponsive event instead of an outage. This stops the downtime model, to be discussed momentarily, from retesting the service after 30 seconds and prevents false alarms. If a critical node is down, setting path outage enabled to true will stop Horizon from sending notifications about nodes, interfaces, services downstream from that critical node. Horizon is trying to avoid a flood of notifications. Within poller-configuration.xml, packages are used to group monitor configuration parameters. Each package must have a package name, filter, RRD element, service or services, and a downtime model. The include range is optional. RRD will be discussed in a later module. For this module, an RRD element will be popped into place consistent with the package and tutorial monitor service. Do not use spaces in the package name. To build the monitor, add the package name, tutorial. Filters provide a mechanism to include or exclude nodes into or from the package. Information can be found in the Horizon reference documentation under Configuration Filters. The overwhelming filter in poller-configuration.xml is that the IP cannot be 0.0.0.0. Parameters are used in filters. The common parameter is IP addr, or IP address. Information can be found in the Horizon reference documentation under Configuration, Filters, Parameters. Use the common filter excluding IP addresses of 0.0.0.0. IP inclusion or exclusion can be a specific value or a range of values. This is effectively another filter applied after the primary filter. Use the specific address of 127.0.0.1. This is being done for demonstration purposes, recognizing that Tutorial Monitor was discovered on 127.0.0.1 and 192.168.159.105. The service element includes the service name, which matches the detector name, the polling interval in thousandths of a second, an indicator whether the monitor is user-defined, and a status. The status indicates whether the monitor is active or not. Add the service tutorial-monitor matching the detector name. The polling interval, low for tutorial purposes, is 30 seconds. This is a user-defined service and the monitor should be on. The SNMP documentation is under Horizon, Reference, Service Monitors, SNMP Monitor. Scroll down a bit to look at the monitor-specific parameters for the SNMP monitor. The tutorial-monitor will use OID, the object identifier of the MIB object being monitored, with the equal to operator, and the operand will be OK. The output of the tutorial.sh script attached to the SNMP extension referenced by the OpenNMS detector. This is what the parameters will look like in the service monitor configuration. The downtime model is described in the Horizon operation documentation under Deep Dive Service Assurance Detect Short Service Outages. And that is the purpose of the downtime model. It is to make an outage shorter if possible. The downtime model is the last part of the package element. It applies to all services in the package. The downtime model that will be used in the tutorial package is configured as follows. When the outage is detected, polling will occur at 15-second intervals for 5 minutes. This is below the service interval of 30 seconds and is meant to show the service up as soon as possible. After 5 minutes, the polling interval will return to 30 seconds for 12 hours, and after 12 hours, the polling will occur at 10-minute intervals. Associate the service tutorial-monitor with a poller monitor class. Since This is an SNMP-related service. Use the poller.monitors.snmp monitor class. Return to the tutorial package and insert the RRD element. For this module, recognize that the RRD step value is 30 seconds and conforms to the monitor interval rate of 30 seconds. Save and close the file. Restart OpenNMS using the system control restart OpenNMS.service command. At some point, run OpenNMS-v status to check whether OpenNMS is running. Return to the OpenNMS login page and log in. From the OpenNMS home page, click on Info Nodes to get to the localhost front page. Scroll down a bit and note that the tutorial monitor is being monitored on 127.0.0.1, but not on 192.168.159.105, as expected and configured in poller-configuration.xml. OpenNMS has been running for several hours now, monitoring the tutorial monitor service. Click on Tutorial Monitor under the interface 127.0.0.1. This page provides information about the monitoring configuration for the tutorial monitoring service. The polling package is tutorial. If a service is contained in 2 or more packages, this helps ID which package contains the service monitoring configuration. The monitoring class and polling interval are provided. The last good and last fail times are given. At this time, the service has not failed. The right column has the Poller service parameters. Scroll down a bit, and the availability is a solid green at 100%. It's time to cause a failure. Return to the console and edit user local bin tutorial.sh. Change what is echoed to not OK. Save and close the file. Return to the GUI and wait a bit. The service goes down. There is now a last fail time. Return to the console and edit tutorial.sh, changing not OK to OK. Return to the GUI, refresh the screen a few times, and the service returns to normal. The availability is 99.944%. This concludes the service monitoring how-to. Up next, Module 8 continues with Part C, Scheduled Outages.